Good morning, everyone. This is Kevin Zhao, your finance professor at MTSU. In this video, we'll go through active risk premium in chapter 7. What is active risk premium, or ERP? Well, ERP is one of the most important parameters in CAPM model, capital asset pricing model. Required rate return of any stock equals risk-free rate plus beta times active risk premium. Active risk premium is the difference between US equity market expected return minus risk-free rate. And this market return is expected return, which means it's future market return. And the nature of ERP is twofold. First one is this ERP is time varying variable, which means ERP can be very different time to time. And fundamentally, this ERP has two determinants. The first one is investor risk preferences, and the second one is economic growth. The higher investor risk preferences, the lower the active risk premium. And the higher the economic growth, the lower the active risk premium. So active risk premium tend to be higher when the market is in crisis, where investor risk preferences are low and economic growth is low. Active risk premium tend to be lower in the time period where investor risk preferences are low, and economic growth is low. To estimate active risk premium, we have two major approaches. The first one is based on historical number. If we believe that what happened in the past will be repeated in the future. This is just the one important estimation method for many financial metrics. We look at what happened in the past, and assuming that in the future it will repeat a similar pattern, then we can utilize this method. Well, let's take a look at active risk premium in the past. Between 1928 to year 2014, the arithmetic average for stock minus T-bill, the rates of stock return minus T-bill return, is 8%, and the stock return minus T-bond return is 6.25%. Geometric mean is 6.1% for stock minus T-bill, and 4.6 of the difference between stock return and T-bond return. So here we tend to use stock return minus T-bond return as a proxy for active risk premium. So in the last 90 years or so, the active risk premium based on historical record is about 4.6%. But when we look at the time period between 1965 and the year 2014, the number declined to 3.14%. And between year 2005 and the year 2014, the number is 2.73%. If we use the difference between stock return and T-bond return, if we use T-bond return as practical risk-free rate, but if we use T-bills rates as proxy for risk-free rate, the number would be around 6%. So historically, I would say, hey, this active risk premium would be something around 5%. And the second approach to estimate active risk premium is through the method called implied active risk premium. What is implied active risk premium? Well, implied active risk premium is active risk premium that we can get from observation of S&P 500 index. Well, S&P 500 is a good proxy for the market return, and if we use stock valuation method, either the constant growth model or two-stage model, then we can estimate implied active risk premium embedded in the current S&P 500 index. Let's take a look at how do we use this implied active risk premium method to get estimation. Well, here's one example. Let's say we are in January of year 2008, and at that time we look at here we are going to use two-stage model to estimate S&P 500 index. And in January year 2008, S&P 500 index is 1468.36, and this number is based on two-stage model, and this is the dividend based model. We use dividend as proxy for cash flow. In the first stage, we assume 4%, about 4% growth rate for the next 5 years. We assume 5% annual growth for the next 5 years, and then the long-term growth rate would be 4.02%. So if we use this assumption and then plug in the number of dividends for the first 5 years, and utilize this two-stage model, as you see in this formula, the R is an unknown. Given we know S&P 500 index, then we can solve this equation to find what is that R, and that R is the estimation of market return. And once you get that R estimation, then you minus the number for Treasury bond rate, 4.02%. You get an estimation of active risk premium. Expected return on the stock based on that two-stage model will be estimated at 8.39%, and minus long-term bond rate 4%. You will get a 4.37% estimation of active risk premium. This active risk premium is time varying variable. In this chart, you see this number changes year to year. Back to 1960s, that number is around 3-4%, and in 70s and early 80s, the number getting higher. Sometimes can be as high as 6.5%, as low as 4%. And right now, in the early 21st century, the active risk premium is in the range of 4 to 6, a little over 6%. I would say on average it's about a 5%. Remember, in this time period, we went through one of the worst recession in U.S. economic history in year 2007 and year 2008, and the market actually recovered from the most recent financial crisis until year 2020. To evaluate foreign equity or foreign stocks, we need to get estimation for foreign active risk premium. And foreign active risk premium equals U.S. active risk premium plus country risk premium. There are three ways to estimate country risk premium. The first one is through default risk spread from the credit rating of a foreign government bond or from CDS market. CDS is credit default swap. And the second method is to look at the relative standard deviation of foreign stock market and U.S. stock market. And ERP of a foreign country equals ERP in the U.S. times the relevant level of standard deviation of foreign stock market and U.S. stock market. And the third method is to look at CDS spread times equity market standard deviation divided by bond market standard deviation. Because this CDS spread is the CDS spread on the bond market, but the equity market standard deviation, the risk can be higher than the bond market. Therefore, we make an adjustment based on equity market standard deviation and bond market standard deviation. So once again, here we have 5 tools in your toolbox. What are they? For US active risk premium, we have two tools. The first one is based on historical estimation. If you believe that what happened in the past will repeat in the future, then it's pretty good for you to use about 5% risk-free rate as your estimation, not 5% risk-free, 5% active risk premium as your estimation of ERP in your active valuation model. And I mean that number is really subject to your judgment on the based on market condition. You look at both investor risk preference and economic growth. And typically, if you expect that the bull market is coming, then you probably want to choose a lower active risk premium because in the bull market, investor risk preferences tend to be lower and economic growth can tend to be higher. And when the market is slowing down or market is sliding into recession, the financial market getting into a chaotic situation, then active risk premium could be higher because on the one hand, investor risk preferences will increase, will increase, which means investor requires higher return for taking certain amount of risk. And second, economic growth could be lower, so active risk premium can be adjusted upward. That's the first tool of estimating active risk premium. And the second tool is implied ERP based on ACE and P500 index by using either constant model or two-stage model. And on author's website, I mean, this text was really good because you have written portion of the textbook, and also you can get onto author's website, and author's website actually give you more information on those key financial parameters, and the website actually updates the information of the estimation of risk-free rate, active risk premium, CDS spread, so on and so forth. So I really encourage all of you to get access to author's website to see those most recent updated information for risk-free rate estimation, ERP, as well as other financial matrix estimation. Now, so that's two major tools you can utilize for estimating active risk premium. And for foreign active risk premium, you have three tools. The first one is based on default risk spread. The second is relative standard deviation of foreign stock market and the U.S. stock market. The third one is based on CDS spread and the relevant standard deviation of foreign active market and foreign bond market. Potential mistake that many people will commit in their active valuation regarding this foreign active risk premium. Well, your goal is not to get this active risk premium. Your goal would be to get required rate of return on a foreign stock or foreign equity. So you use this CAPM model. Expect rate of return equals foreign risk-free rate plus beta times foreign active risk premium. So the common mistake that people make here is to double count country risk premium in both risk-free rate and ERP, right? Because if you use foreign risk-free rate plus foreign active risk premium, then you double counted this foreign country risk premium, which overestimates required rate of return on a foreign stock and underestimates the price of a foreign stock. So the best practice here is you add this foreign country risk premium in either risk-free rate or ERP. You don't do both. And it's better to add this country risk premium on ERP than risk-free rate. Because when you do risk-free rate, it's more on the bond side. But when you add this country risk premium on ERP, you actually consider the nature of the equity. So that concludes our discussion on chapter 7, risk-free rate and active risk premium. So far in your toolbox you have 12. You have 12 professional tools, 7 tools that you can utilize to fix estimation of risk-free rate, and you have 5 tools to deal with this active risk premium. So before we wrap up this chapter, I would like you to answer this question. What are 7 tools that we use to estimate risk-free rates? What are 7 tools? What are 5 tools that we use to estimate active risk premium? So I want you to review the chapter, review the PowerPoint as well as this video to answer this question, and practice your exam questions. I mean, here I combine homework and exam in the same practice. So you only have 3 exams. All of them are take-home exams. First exam has 7 questions. They are from end of the chapter questions and problem, and they are I think they are even number questions. So before you tackle those even number questions, what you needed to do is, first of all, go through chapter thoroughly, understand those professional tools that we covered in the class. Right? I mean, we don't have a lot of theory to discuss. It's all very practical tools that we discussed in the class, either a certain technique or certain method based on different perspectives. And the more tools you can utilize, the better the estimation that you can get as a professional financial analyst. So I highly encourage you to start working on your first exam. I don't want you to push all the exam questions towards the deadline. You won't have time. You won't have time to fix all of them. So it's better to do this step by step. And this week, I think you should be able to fix at least 4 or 5 questions in your first exam. First exam is pretty straightforward. I want you to use Excel spreadsheet to solve those questions. On your spreadsheet, first of all, you should reinstate the question that you read from the chapter, and then you build your spreadsheet model. Right? And in a typical spreadsheet model, you have 2 areas. The first one is the inputs, and the inputs of the variable they are going to use in your model, and the second one is solution of the problem, and this solution should be a formula. So once you submit your exam to D2L, I will look at your exam solutions by clicking on those cells to see if those are formulas or just a number. I want you to put formulas there, because if I see formula, I see, okay, here's the process that you use to solve the problem, not just a number. I mean, you could put a number there. It could be a 100% accurate number for that problem. In that case, you will get a full credit. But if not, then there's no way that I can give you partial credits. So I can tell you that for most questions in your exams, it's unlikely that you can get a 100% accurate answer. But if you could go through major steps to get the solution, then you will get a majority of the partial grades, even when your answer is not 100% correct. Let's say cost of capital for a company should equal to 8.37%. That is the correct answer. That is 100% accurate answer. But you need to go through several steps to get that answer, and I will look at your solution to see if you go through certain process 1, 2, 3, and those steps will be reflecting the formula that you build in your Excel spreadsheets. Right. So even when you get like a 5.3%, of course, it's way off the track of the right answer, but you may get 9 out of 10 as your grade, because I see the process solve for this problem. And you might make a small mistake. It could be a typo. It could be a small mistake, but it's okay. You got a majority of the credit on that problem. So once again, I want you to spend a lot of time reading through the chapters, pay a lot of attention to those illustrations, and work on your Excel spreadsheets for your exam problems and questions. I hope you enjoyed this video, and I will see you next week. Thank you.